Hello, it's Duncan, back in my office by popular demand. In the last episode, we used the experimental Kotlin context receivers to trace code that does input or output, and is therefore not a nice pure calculation through our system. I think that it went well, but we were left with a couple of issues. The first is that we had to add code to all tests of IO context functions to allow them to run. There are a lot of these, so it became quite a pain. The second is that context receivers don't play well with the higher order retry function that we use to work around network errors. We'd like to reduce the overhead of using IO context as far as possible, otherwise it may increase rather than decrease the complexity of our code base. So today we're going to look at adding some context receiver conveniences. Quite a long time ago now, I had this idea for injecting a fixture into a JUnit test as an extra receiver, as an extension method here, so that inside this method, this is an instance of this fixture that is supplied by a subclass. This lets us separate out the fixture from the test lifecycle, which is quite handy occasionally. And we wrote this fixture resolver here, which is a special little bit of JUnit that allows JUnit itself to inject this parameter. And when I say inject this parameter, that's because, in fact, when we have multiple receivers, this is compiled as a method that takes the parameter of the extra receiver, this one here. Now, we saw when we first started looking at context receivers that there was a relationship between extension methods and context receivers. And it turns out they're both effectively compiled to the same thing. So in fact, we could, now we're using contexts, right here, context of fixture, and remove this extension receiver. Now you see that compiles. This client here references the client inside our fixture. So fixture is in fact a receiver inside here of this by dint of this context fixture, as it was in these other ones by dint of this fixture dot. We'll just run to check that's all true. And by the way, that new big test bar there is courtesy of Dmitry Kandilov. Thank you very much, Dmitry. I hope we'll do an episode on your plugin. Okay, so far so good. That means we can get rid of this one here and replace it with a context. And the same here. And that's a lot. Check that. And we're good. Before we go on, we'll just remind ourselves where this fixture is got from. At the top here, we're saying extend with this fixture resolver class. And the fixture resolver here says, I've got some interface that's fixture source. When JUnit asks me whether I support a parameter, I'll say true because I'm the only extension we're actually using it here. And when I'm asked to resolve the parameter, which we know will be this fixture type because at the moment that's all we have, then we're going to go to our extension context, which is the class. I'm going to say, is that a fixture source? And if so, it's got a fixture. And we'll return that. And this fixture source is implemented by this class, and the fixture is passed in by subclasses. So our fake value of test passes in a base fixture with some variations. Well, that's all very well and a little bit hacky. It's certainly very specific to this particular contract. But we can extend with more than one fixture resolver. Why might we want to do that? Well, because each one of these tests has run IO in here. So what actually we'd rather like here is that we were context of fixture and IO, because if we were, and I removed that, then we'd be able to get rid of this run IO in our tests. And that way our tests communicating that they need to be doing IO by this context, but they don't have the boilerplate of this little block here. So how could we make that work? Well, I'm going to say we're going to extend with two things. We're going to extend with a fixture resolver and an IO resolver. Now that doesn't exist yet, so let's copy the resolver we've got down here. Duplicate that, and we'll just change this to be IO resolver. Okay, I'm going to try running just to see how far we get. And we get a failure here with multiple arguments applicable for context receiver. And that's because this magic now can be putting either fixture or IO out of the context. I think the compiler could try harder because there's a client here actually only needs IO, but we can hint by saying this magic is magic of IO. Now IntelliJ isn't as clever as a compiler, because it thinks it's unused. But let's see whether it gets us compiling. It does, and we run, and we're now failing, but we fail the tests with discovered multiple competing parameter resolver for a parameter, which is our fixture. So what's going on there? Let's look down here. And the issue here is that we have two parameter resolvers, both of which say true for a particular parameter. So in fact, we could fix that to some extent by saying false in this one and run. And that would change our error. And the error we now get is that this parameter resolver is giving us a value for IO, which isn't what we want. Okay, up here then, our fixture resolver doesn't always want to return true. It wants to return true only if the parameter it's trying to resolve is the fixture. So we can say that this is the parameter context. Parameter type is our fixture. From here, Java class. And similarly, I think in our IO resolver, we want to resolve if our parameter type is IO. Now the fixture one will only supply the fixture, but the IO resolver wants to supply IO. And there's a single instance of IO that we can return here. So we can get rid of that. And we don't need this. And we can try and run. And all our tests pass. Brilliant. So now we've got an IO resolver. We can use that in our other tests. This one will take IO. And we don't need to run IO. And this one needs IO. Oh, in fact, it doesn't because it never actually uses the client. Fix up this magic. And we can remove this and run. Good. Now it seems there's a bit of duplication between these resolvers, but not enough that I think I care. So I'm going to move this out as a general thing. Let's see where to put it. We have testing, asserting, faking. Let's have new Kotlin class of resolving. And now we can move IO resolver. We'll do it by hand into resolving. Import it in here and run. Wonderful. And now we can look for other tests that used run IO. So I think we'll say, let's find our run IO. It's here. We'll find callers of that in tests. And we have the price stock list loader tests. So let's try and fix those the same way. We'll go to the top. We'll add extend with IO resolver class. And now we should be able to say in here, this is a context. IO doesn't need to do that. Run to see if it works. And it does. So we can do this one. That one. Splendid. And I'll just fix up the rest of the tests in fast forward. Phew. Finally, the last one left here is in fixture where we save. Let's just have a look, see where that's called, see whether we can be bothered to mark it as a context function, and I think probably we shouldn't. We should just leave that alone. Okay, run the test one last time. And I think we can commit that as add IO resolver for JUnit and commit. One warning, and that we know is something not really understanding inline classes. Commit anyway. Good. Okay, now we're going to look at a thing that I skipped over last time, which is interfacing between context functions and higher order functions that don't understand about context. The problem we were left with was this retry here. If we look at that, you'll see we had this function here that converts a function that takes a T and returns an R into another function that takes a T and returns an R. but it retries if it throws an exception. So we've got this loop here, which does the retry. And if there is an exception, it's reported to a reporter, and it retries many times as we ask it to. Now, our problem is that the function that retries doesn't have a context receiver. And because of that, we can't just pass our pricing into the function as we did before. We've had to run IO inside the lambda here so that the function that we pass in here isn't a context function anymore. Now, that's okay with context of IO because we can just say run IO anywhere here. But if it was a context that carried any real information with it, then we would want this retrying pricing here to use the same context as this function. As it is, this context is lost. We lose it here, and we pick a different version of it effectively up here. So let's see if we can refactor in order to convert this retry into a context function. The first and easiest way of doing this is to note that this property here could be a computed property. At the moment it's backed by a field, so this code is called and then set into this field. But if we made a computed property, so we'd say it's a getter, well, it would lose access to this pricing now, but we can solve that problem by making this actually a property. And now computed properties can have contexts. So we could say this is context of IO. And if so, we can take that out of there. We'll run the test to find out, which is rather clever. I do have a philosophical objection to it though, and that's based around the fact that I think the properties should only be calculations. As soon as we make retrying pricing a context of IO, it becomes an action. It depends on when and where we call it. So if we're not doing that, what can we do? Well, one thing we could do would be to evaluate it when we need it. So in here we can say, make this a block body, and then we'll remember retrying pricing. I'll call it R for now. And we'll put that in there. And now we'll inline this. And run. Good. So this is a way to kind of adapt our retry that doesn't know about contexts to a function that does need a context. Let's see whether we can extricate it from this function. The first thing I'm going to do is extract this expression into its own function. I don't know what to call it yet, so function will do. And at this point, IntelliJ doesn't know how to extract a function that requires a context, but we can solve that by adding this back in here, I think. So now really we're just back at our getter. Now I want to make this function not depend on the details of this pricing, but any old context function. So let's say if we can extract just that as a parameter. Looks good. Oh no, we can't. So in here we'll say val p equals pricing. We'll give that a type, which is what we expect. And we'll extract that as a parameter and replace both of those. Try running that. But we're still good, and that means we can inline this p. And drop this down so you can see it. And we'll look at what this returns, the type. Well, the type is item to price, but I think what we actually want is we want to return a function with a context. So we want to make it context of IO, item to price. And to make that work, what we can do is we can make this a lambda, which will itself have a context. And inside that lambda, we can build our retryer. And then we can invoke that retryer on the it that comes from the lambda. Now you see that compiles, and in fact when we do that we don't need this context IO here. Now that should make the type of this R here our context function. Let's have a look. It does, and that's why this isn't compiling here, because it price by, which is stock list price by, doesn't take a context function. But it should do really, because that's going to use IO. So now we can put that in here. And that then doesn't work here for the same reason, that this is context of IO item to price. But now this function, because it's calling a function that needs context of IO, needs context of IO itself to run. And we can use our little magic in here. Although we do have to tell it that the type is IO. And then finally we had the same problem here. So this is context of IO. All right, that's made everything a bit more complicated, but at the same time a bit more right, because we're actually expressing that both this function and this function need to be doing IO to work. Does it all still run though? Well, yes, that's a relief. Okay, back up the top. Let's have a look at how we're doing. We're now in a position to call this our retrying pricing. And we can move that out of here, making it private. So we're nearly back to where we were, and this now doesn't need to be a property. Again, we'll check. Good. Compared to the previous solution, we still only really push things around. We're still having to rebuild a retryer here every time we call this function. But that's okay, because no actual work is being done in its retry function. Now that we can go one stage further and extricate this retry function from this function here. How can we do that? Well, retry is at its heart just a function that takes one function that takes a t and an r and returns another function that takes a t and an r. We tune it with retries and reporter, but this function is its fundamental parameter. What we're going to do then is reduce this expression to something that just takes this function rather than all three things. And that means we want to partially apply the retries and the reporter. A partially apply means that we remember these two bits and return a function with only one parameter, this one. So what would that look like over here? I want some sort of f that's going to be a function that takes a function from item to price and returns a function from item to price. And we can define that with a lambda. And that lambda is going to call retry with 1, and our reporter is report exception. And then passing in it, which is a function. And then we can use that in place of this retry. So this bit of the retry has the two parameters. They are here now. So we can put an f in here. Can we? Well, it compiles. Let's see whether it runs. Splendid. Now we can pull this f up as a parameter. So we'll go in here and take this lot as a parameter to this function. Now IntelliJ is really not very happy, but it should be, I think. Let's get rid of that. So if we get rid of this here and remove this silliness and run, then we're still good. And now we need to do is tidy up. So this f we can inline. Leaves it behind for some reason, but that's now unused, so we can get rid of it. And now we have a function that takes two functions, one of which is a context function, and the other one is a mapping of the type of that context function without the context. But the good thing, though, is that this has been extricated from any of the properties of this price stock list loader now. So we can take this thing out of here and move it somewhere else. And for now, I'm going to put it into here. We'll make it public, and I don't have a better name. I'm going to call it contextualize. We'll come back to it in a minute, but you can see where it's used. We're able to use it to convert a context function here and a high order function retry here that doesn't know anything about contexts to the context function itself. We can use that in here nicely. So now let's go and tidy up over here and see what this means. So we'll separate it out. We've got two functions, and we can inline this bit. We'll run just to check that's still true. Good, good. And now let's generalize this. This function here we'll call context function. And this here is a mapping. Maybe it's a contextless mapping. Now this is very specific to particular types, but we can fix that. So we'll say refactor that. We'll introduce a type parameter for a context. We'll call that C, and we don't care whether it's I or not. Now this input type here, another type parameter. T I think is good for that, just the type. And we'll replace all of those. But again, we don't care that it's item. And finally, this price question mark, same thing. Make a type parameter. It's going to be R for our result type. And again, we don't care whether or not that's price. Run to see whether we're doing well. And now there's an issue here that IntelliJ added one of the type parameters and not all the others. Well, I think we might be able to get rid of that altogether. Let's have a look. It turns out we can, and run. Good. Looking at this and thinking it through, I think maybe if we were to call this transform, and then make this the receiver, then we could call this transform, maybe transformed by. And now in here, we'd have that our retrying pricing is our pricing transformed by retry. It's tempting to call this map, but I really don't know what it is. I do know we've got two its here though. So I think I'm going to call this one outer it, and this one is inner it. Once you've written something that's simultaneously as general and specific as a function like this, you do end up with sympathy for the problem that functional programmers have naming things. I'm going to stick with transformed by. Luckily, I'm not enough of a computer scientist to understand what this actually is and give it a proper name. Also, please don't think that this comes easily, at least to me. It took me a week to come to the conclusion that a function like transformed by could be written, and then several hours to work out a refactoring to get there. And I certainly consider I'm very lucky to have the time to put into this sort of thing. I think it's time to check in. Just before we do, we should work out where this should actually go, and I wonder whether wherever we put magic is probably the answer. So I'm going to copy this, go to where magic is. Oh, it's in IO. That's not a good place. Okay, let's fix all these things at once. Let's go here. Let's find somewhere. We've got our foundation package here. I think I'm going to create a new Kotlin class of contexts. I'm going to call this Kotlin file. We'll add that. We'll move this into contexts. I think it will be the file that exists already. We will find out. Yes, good. And the same with magic. So we'll take magic from here and move it into contexts. So context now has our magic transformed by. That should probably go up. Tiny, tidy there. Run the tests. And commit. And this is going to be introduce transformed by for adapting higher order functions to context. Good. Well, I have to admit that I was pretty proud of myself after that. But programming is nothing but humbling, because I went to look at Slack just before I got on to looking at a time context, and I saw that I had a message from Yusuf Shoaib. He has a solution to this issue of transforming a non-context-aware function into a context-aware function that I think is a lot more elegant. So let's have a look at that rather than time. We wrote this retry function quite a while back, and I'm not sure that I pointed it out at the time, but it does have quite a limitation, and that's that it can only retry a function that takes one argument and returns a result. If we wanted to retry a function that takes two arguments, well, we've got no way of doing that here. We really just have to duplicate this entire thing and say we've got a T1 and a T2, and we take a function that takes a T1 and a T2 and return a function that takes a T1 and a T2, and inside here there is it1 effectively and it2, which is our T2, and this function takes it1 and it2. But that doesn't solve the problem for 3 parameters, so we have to have more code for that, and 4 and 5 and so on. Interestingly, Andrei Breslev has said that variable numbers of generics is a feature that they considered for Kotlin, but we don't have it, and so it doesn't solve our problem here. Now we can finesse this a bit. We can use a single argument function with a tuple. So we could retry a function that required 2 arguments by passing a pair, but we would need to construct that pair on the way in and deconstruct it to pass it to this function. Yusuf's suggestion is that we solve the problem with our output type rather than our input. So let's delete this one and see how that would go. You may remember when we looked at the reader monad, we solved the problem of passing context to a function by returning a different type rather than having a different parameter. What Yusuf suggests is that our retry should return a type that he calls a wrapper. And the type looks like type alias for some R, a return type, and that's going to take a function that takes nothing and return an R. And we're going to call this wrapper. Now let's write a version of our retry function that returns this wrapper. So if we did, copy this, and we'll put it here. And now we're going to return not a T to an R, but a wrapper on our return type. And we're not going to take a function at all, which means that we don't need this T. Okay, so now we need this function to be wrapper, which means it needs to take a function that takes nothing and returns R. So it will be nothing to R and returns R, that's good. And now in here, we can return an R just by invoking our it function, and we have no parameters. So that compiles, which is good, but it is a little bit confusing, so we'll call this F for function. Now we've got tests for our original retry method. So if we can implement our original retry method in terms of this one, we'll have confidence that we're on the right lines. So let's just run all our tests to warm things up. Good. And now let's look at retry, the original one. So now we know we don't want to do this in here. I'm just going to replace it with a to-do, keep everything compiling. Now what should we do in this function? Well, we want to use this retry. So we will say, this is going to return a wrapper. So we've got the wrapper, and that's going to be the type of our wrapper of our result. And that's going to be retry, calling this other function with the number of retries and the reporter. Move that over there so we can see things. Now that wrapper is a function, so we can invoke it with wrapper, and it takes a function that takes nothing and returns R. Well, we've got here a function that takes a T and returns an R, but we've got a T here. So we can say, let's give that a lambda that takes our function and calls it with our T, which is the it up above. Now we know the type of that is going to be R, and we know we need to return an R, so we can just return that. Is that true? Well, the test will tell us. And they say yes. Now we can pull this calculation here of what the wrapper is out of here, and we can convert this function to a lambda. And I don't know what that block is doing there. Good. Okay, so now our tests of retrying work with this retry that uses that one. Now let's see if we can generalize what we've done here. What I think I'm going to do is I'm going to take this thing and make a function out of it. Now that seems to have an issue. Let's have a look. Well, it looks like the extractor's lost the type of this. I think this should be wrapper of R there. And the compiler seems to agree, so let's run that. Good. And now let's remind ourselves what that's doing. It looks like that. Now, if I make this function here the receiver, you can see we've got a function and we're doing something to it. Well, this is a wrapper, so we're wrapping it. So we could say function wrapped with a wrapper. Good. Now I can inline this wrapper and make this an expression body and get rid of the unused types. Now I'll make this public and lay it out so we can see it a little better, and specify the return type because otherwise it's easy to get confused. Now back to our tests. I'm going to take a copy of this one and we'll say, let's do it raw here. And in here, I'm going to inline this retry, just this one. And now you can see when we do it raw, we just sort of reverse the order of these parameters. Instead of calling retry, passing our function, we decorate our function with retry. Now the beauty of this approach though is that we can take this wrapped with and we can duplicate it, and we could have a version that took no parameters. So there'd be no T, this would take no T, there would be no it, and we just invoke the function with no parameter. In which case we have no T. So we've got a version now with no parameters, a version with one parameter. What would a version with two parameters look like? Well, let's fill it in by hand. It would have a T1 and a T2. It would take a function that took a T1 and a T2 and return an R. It would return a function that took a T1 and a T2 and return an R. And it would have it1, which we'll call T1, and a T2 as parameters to the block, so that we can pass them into there. And you can see that we could write versions for 3, 4, 5, 6 parameters. Now we'd have to write all that code, but it would mean that we could have retries of multiple parameters, but also other decorators. So for example, we could have a decorator that timed out a function if it didn't complete quickly enough. Before I go on, I think I've just got the order of these parameters a little bit skew, so I'll change them to be a little bit more sensible. So this should be T1, T2, and are, so that they're in the order that you'd see them in a function definition. Okay, so this technique has allowed us to write a more generic version of our retry, one that's able to operate on functions with different numbers of parameters. But what does it have to do with our price stock list loader? That currently takes a pricing function, which has context of IO, an item and price, and uses our transformed by, the one we wrote a little bit earlier. But here's the cute bit. If we use wrapped with, and instead of passing it a lambda, we pass it our new version of retry, the one that doesn't take a function, that compiles. And not only does it compile, but it works. What's going on here? Well, we get a clue if we see which version of wrapped with is called here. And the answer is the one with 2 parameters. But it looks like we're calling it with a function with only 1 parameter, this item. Under the hood, though, context functions are just implemented as functions that take another parameter, in fact, the first parameter of the context. So in fact, this function type here is the same as a function that takes IO and item. And that's why we're using this 2-parameter wrapper. So it's also true, for example, that we could replace this function in here with IO and item, and it would be happy. And in fact, we could use IO, and off to work we go, and remove that. But if we do, then we have to chase that all the way down through here, which I won't do now. So there's sort of a difference between function signatures and the function types. If we start declaring context as a part of the function signature, then we need to use context all the way down. But as soon as we end up with a function type, we can swap from context IO to IO and item, from context to a first parameter. That's a bit confusing, but a similar sort of thing happens with extension function receivers, where we can call extension functions passing the receiver as the first parameter. I think that keeps things compatible with the JVM and with Java code. Anyway, let's undo that, and that, and that, and run the test one more time for reassurance. Good. I ended the discussion on transformed by saying it had taken me a long time to work out that it was even possible, and then quite a time to work out the refactor. I think I can confidently say that I would never have come up with this wrapper idea. As I get used to functional programming, I am learning to look to solve problems with the return type of things rather than the parameters of things. So huge kudos to Yusuf Shoaib for getting his head around this little lot. Just before we wrap up, no pun intended, I think that there are a couple of things we can do. First of all, we can make these in line, although this will need to be cross in line to make that happen. Cross in line basically means although this is a function, we can't use a lambda that would do a return out of its scope. That could be in line, that could be in line, this could be in line, although it's unused. And now we'll take these and pull them into their own file. I think we'll call it wrapping, although I wonder whether decorating wouldn't be a better name long term. That, and refactor. And nothing has happened. Rather strange, never mind, let's cut. Create ourselves a new file in here. Add, paste, run. Move this to the top. And I think we're done for the day. We had the moral question of whether to keep this unused function here. I think I'm inclined to for now, just in case it comes in handy, but maybe just say replaced with, wrapped with, and commit. See what's wrong. And we have 2 functions that we're not using. I think I'm happy with that. Well, all this functional programming cleverness means that I didn't get around to the contexts and actions cleverness that I had planned for this episode, but at least we've cleared the decks. So the next week we can look at my rules of thumb for when we should use context and when we should use plain old parameters. I'm sure you're going to want to watch that as soon as it's published, so please subscribe to the channel if you aren't already. And if you enjoyed this, I think you'll enjoy the book that I wrote with Nat Price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.